Hey folks, and welcome back to our next calculus lesson. We're going to continue with minimizing path problems, and we're actually going to show a different way. It involves the tiniest bit of trigonometry. Before you freak out saying, "Oh no, trig!" Just watch. Easy peasy. Let's take a look. So we saw this problem before. In fact, if you want to go right back to your notebook and take a look at it, cool. We're going to do it in a slightly different way. We're going to show that sine of an angle is equal to the slower over the faster rate. Now this angle is actually right here. So if we can find this angle using sine, then we can find what's going to be fastest. It sounds more complicated than it actually is, so let's just take a look. In this problem, we know, well, sine of theta is just equal to 2 over 4, because the slower speed was 2, the faster speed was 4, which means that theta is just equal to arc sine or inverse sine of 2 over 4. Plug into the calculator, that means it's 30 degrees. So let's just draw our little diagram out a bit more here. We know this is 30, we know this is 3, we're trying to find this distance. Well, if that's 30, this is 60 because they make a 90-degree angle. And then I know tangent of 60 is just equal to 3 over x. X is equal to 3 over tangent of 60. You plug this into a calculator and you get same thing we did before. Square root of 3. And it has this small amount of work compared to this relatively difficult amount of work. And the nice thing is this actually has 0 real calculus in it. Kind of cool. So that was a lot easier than the first way we did it. And kind of straightforward. Now you might be thinking, okay, one example isn't really the best in the world to see this new thing in process. I need another one. Cool. Let's take a look. So here's our next problem. You might want to take a second and just write it in. Pause the video if need be. Now, diagram definitely helps, so let's draw one. Okay, so here we have our diagram. Subdivision is going to be built here. Main connector to the city is here. We know that this is 400 yards down the street. I should add that in. And there's some distance x, which is the most cost-effective way of doing it. We're going to do this using our new method. So it has to be 50 over 75, because it's always going to be our smallest over our largest. That means that theta is equal to inverse sine of 50 over 75. And it turns out that's going to be about equal to 41.810314.9 blah 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 degrees. Make sure you're in degree mode for this, or else you're going to get in radians. It's going to be really annoying. So that means that this is going to be about 48.189658851 degrees. And then we can just set up tangent of, let's make our lives easier and just say 48.1896. Okay, I tried to round, but there's no good place to round here. It's just equal to 50 over x. Well, that means x is just equal to 50 over tangent of this obnoxious number. And that ends up equaling 44.72 feet, or excuse me, yards. So that's this. That is our most economic way of putting this pipe in for the subdivision. Done. Cool. So we've seen 2 examples using this new method with sine and tangent. Give the homework a shot. Some of them are exploration problems, which are just walking you through, and some are straight problems like what we had in this classwork and last homework. Either method. Use whichever method you like. I would recommend for the exploration ones definitely doing this because, hey, it says to use it. But for the ones that don't say to use one method over the other, use whichever one you're comfortable with. If you have any questions, see me during office hours 10 to 11 and 2 to 3 every single workday. And other than that, folks, I'll talk at you soon. Hope all is well, and stay safe.